Hello everyone, welcome back to Pre-algebra with Miss Betsy. We're beginning a new topic of instruction today. We're going to be talking about how we calculate area and volume. Before we get started though, you know I've got to have a lame joke for you, and this one, even by my standards, is really, really bad. This is on the kids' funny lame joke page or something. Corny jokes. What did baby corn say to mama corn? Where's popcorn? As promised, I suspect that I never fail to reach the expectations that you have when I tell you it's going to be a lame joke, because you know that you can count on that. If you're using the same text that I am in Chapter 12, page 399, section 12.1, which is Area of Rectangles and Parallelograms. For my text, I'm using Pre-algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the original first edition. You don't have to have the same text I do. You find area of rectangles and parallelograms exactly the same way no matter what text you're using, no matter if you're learning this when you're in 6th grade or when you've gone back to school and you're 50. So let's just dive right into this, and let's talk just a tiny little bit about what area means, and as always, we've got a fair amount of vocabulary we're going to be working with in this section. So if I have this little square here, and we take the measurement, we have the measurements of this. This is a centimeter on each side. It's 1 centimeter, 1 centimeter, 1 centimeter, and 1 centimeter. You could just as easily use dimensions of an inch or a foot or a yard or a mile. We're just talking about where the length of each side is 1 unit. Whatever that unit is, whether it's centimeters, whether it's inches, whether it's feet, whether it's miles, the length or the measurement of each of those 4 sides is the same, and it's simply 1 unit. Units, like I said, centimeters, inches, millimeters, decimeters, micrometers. When it's 1 on each side, that's called a unit square. And we use the idea of a unit square when we're defining what area is. Now let me go ahead and read this from our text. Here it says, area is the number of unit squares needed to cover a surface. And you see these unit squares all of the time in the world around you, whether you realize it or not. You think, how in the world does algebra impact me? Well, you see unit squares all over the place. Think about going into a restroom. You see the tile on the wall in the shower. Those are unit tiles. Well, when they're square tiles, they're unit tiles. There's so much fancy tile work out there now with different shapes and sizes and rectangles and patterns. But I'm talking about old-fashioned square tiles on the wall of a shower. Square marble tiles or stone tiles that you see that you walk on. Really old-fashioned linoleum tiles, vinyl tiles. You have parquet wood flooring that is square wood tiles set into a floor. And those are unit squares. So when you have a floor, the area of, I'm standing in my dining room right now, and I don't have square tiles in my dining room, but if I did, the area of the floor of my dining room right here would be the number of tiles, of those square tiles, that I could count in my floor, and that's all area is. You know, area is different from length, because all you're doing when you measure the length of something is how far it takes you to walk in one direction, or you're using a ruler or a meter stick, and you're seeing just a linear distance. Measure it like that, length. What you have when you have area is you add a second dimension, which we call width. And it's like having what we're talking about right now. We're just going to talk about a rectangle. We have the length and we have the width. And the area of this rectangle right here is the number of unit squares that it takes to cover this whole floor here, if you will. Now you're going to bear with me. We're going to make the assumption that I can draw perfectly here and divide this rectangle up into squares that are unit squares, meaning that they have the same dimension on all four sides. And obviously, looking at this, this is not perfect, but you're giving me grace here. How many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the area of this rectangle here is 12 square, and I'm just going to say units here. Remember, at the beginning of this lecture we said that if you have something that's the same dimension on all sides, the same measurement, it's called a unit square. So we have 12 square units. We don't know what these units are. So let's just say that my rectangle that I have drawn here is 4 inches on one side, and it's 3 inches on the other side. 1 inch, 2 inch, 3 inch. So I have 3 units. 1 inch, 2 inch, 3 inch, 4 units. So instead of saying that the area of this rectangle would be 12 square units, we would say that it is actually 12 square inches. So that's how we define the units of area. We use square inches, square feet, square miles, square yards, square millimeters, square centimeters. And the square comes from this very obvious visual right here that we have the unit squares. How many tiles does it take to fill up that area? Okay? So let me use these couple of illustrations that we have from our book. I have this one rectangle, and I have another rectangle, and I should have left the one on that I just erased. But it never hurts to, whoa, pretty slanted line there, isn't it? Let's see if I can do a little bit better. And we're going to have this be divided into 12 units. So what dimensions do we have here? We have 1 centimeter on this side. These are the same units. So the width is going to be 1 centimeter. The length is going to be 2 centimeters. How many squares do I have to cover this area? Well, I have 2. So the area of this is 2 square centimeters. And using your exponent of a 2, this right here means 2 square centimeters. You can always write out 2 square centimeters. If you prefer, you can write the whole word. But you're going to most frequently see something that looks like this, 2cm squared. Okay, now the second one that we have here, if these are the same unit squares, where we have a centimeter on each side, this width here is 2 centimeters. This length rather here is 3 centimeters. How many unit squares? I have 6, so the area is equal to 6 square centimeters. Right here, 1, 2, 3, this is 3 centimeters of width, 4 centimeters of length. And how many tiles do I have here? Well, we know that we have 12. So the area of this larger rectangle is 12 square centimeters. Now some of you already know where we're going with this, because there's a formula that you always use when you find the area of a flat surface. I want you to notice. 2 times 1, 2 square centimeters. 3 times 2, 6 square centimeters. Finally 4 times 3, 12 square centimeters. And we've learned that using this exponent here of a 2 says we're going to use that centimeter is used as a factor twice. So we have centimeters times centimeters. And if I just spoke Greek to you, don't worry about this. Just know that the units of area are always square units because it's like you have that little square floor tile. So length times width gave us 2. Length times width gave us 6. Length times width gave us 12. And that's exactly the formula that you're going to use when you find area. The area of a rectangle is equal to its length times its width. Area is equal to length times width. And they sort of use a script, a handwritten or a cursive L and W. And they're going to start off putting that dot in there to indicate multiplication. You don't even need that. Area is equal to length times width. And that's what you're always going to use when you find the area of a rectangle. So when you're doing your problems, and I say make sure you show your work. What's the very first thing that you're going to want to do? The very first thing that I want you to do? So I want you to write that actual formula out. We have a problem that says find the area of the rectangle. And you have this picture here. And it says 6 centimeters and 14.8 centimeters is our picture. What did they ask you to do? They say find the area. The very first thing that you do is write the formula to find the area of a rectangle. And you must memorize this. There are different formulas, different patterns that help us calculate how many square tiles it is for each object. So this is for the area of a rectangle. Area is equal to length times width. And because we know that our units for area are always square units, I'm not going to make you write down the centimeters at this level of class. As you progress up in math and science, you'll need to be more careful with that. But for now, we just want to get to grasp the whole concept of area. So the length is 14.8, and the width is 6. Notice that I didn't put that raised dot in there. I didn't use a multiplication sign. This means 14.8 times 6. Do your work out to the side. I did say that you could use a calculator now. 6 times 8 are 48. Carry 4, 24, 28, carry 2. Make sure that you locate your decimal point accurately. You have 1 decimal point. So your answer becomes 88.8. So the area of this rectangle is 88.8. Now am I finished? No. There are always units associated with area. Since we're told that these are centimeters, this would be 88. The area of this rectangle is 88.8 square centimeters. It could be anything. 88.8 square feet, 88.8 square meters, 88.8 square units. If we didn't have them labeled, the area is not just 88.8, but it is 88.8 square units. Okay, that's all you do to find the area of a rectangle. And we're going to go ahead and I'm going to show you something pretty cool. I tried to cut paper for you to make this look a little bit better, but Didn't succeed very well, so I'm going to sketch this on the board. We're going to talk about a parallelogram. And what a parallelogram is, you can see this basic shape when you drive back into the country or into an older area of town or a place near where you're at, and you see, or maybe Grandpa's house, and he's got an old barn that when it was built, it was nice and square, but over the years it's tilted some to the side, you know, so it's, but if you straighten it back up, it's a rectangle. Tilt it to one side. It's what we call a parallelogram. Make sure you know your vocabulary. A parallelogram is an object. It's a quadrilateral, means it has 4 sides, and it has 2 pairs of parallel sides. The widths, if you will, the lengths, if you will. 2 of those sides are parallel. And I've alluded to the way that we're going to arrive at the area of a parallelogram by saying, remember Grandpa's barn leans like this, but if you straighten it up, what do we have? We have a rectangle. So our formula to find the area of a rectangle is very similar. The area of a parallelogram is very similar, but let me show you something. Want to put a dotted line in here. Okay. Going from here to this opposite end, this means that this is perpendicular. This is called dropping a perpendicular. Don't worry about that for right now. But if we sketch this little triangle in here, and if you were actually to cut that triangle out, you would have, let's see if I can do this. We're going to cut the triangle out, or off, and this is what our object looks like now. Because we've cut that piece of the triangle off so that we have 2 square corners here. We're going to pick this piece up and we're going to glue it on at the other side. There's our little square corner right here. So we've actually physically picked up this piece of the parallelogram that we cut off. It's the same. And what is this visual sketch showing us? It's showing us that because of the fact that these 2 sides, each pair of sides is parallel to the other, that the inside of a parallelogram, the inside area of a parallelogram is just exactly the same as the area of a rectangle. Now what you're going to see is that instead of saying, I said this is like we have 2 lengths and we have 2 widths, with a parallelogram, and let me write this out for you, parallelogram. It's one word, a parallelogram. Parallelogram, we don't talk of it as having length and width. We talk of a parallelogram as having a base and a height. So here's our parallelogram. The base is what the parallelogram sits on. The height is always going to be indicated for you, and you know it's the height because they're going to have that little marker there that indicates that we have a right angle. You can have it in 2 different places, both of these. Either of these could be written in your problem, and they might say this is like 2 centimeters. And what's the formula to find the area of a parallelogram? Well, the area of a rectangle is the length times the width. The area of a parallelogram is the base times the height. And that's all you need to know to be able to calculate the answer to this problem. So we have an example, and it says, find the area of the parallelogram. Nothing ambiguous about what they're asking you to do at all. Here's your parallelogram. You know it's a parallelogram. We have it written like this. This says 4 centimeters. Down here this says 9.6 centimeters. Our instructions are, find the area of this parallelogram. Very first thing you do, because you have to show me your work, you have to learn these formulas. You say that the area is equal to the base times the height. The area is the base, which is 9.6 centimeters, times 4 centimeters. We know that's the height because it's a dotted line. It has this little square in there to let us know it's perpendicular. Now we do our multiplication. 9.6 times 4, 4 sixes are 24, carry 2, 36, 38. And we have the area is 38.4. But you're never finished with area problems until and unless you give us a unit. Units of area are square units. These are indicated to be centimeters. So the area of a parallelogram with a base of 9.6 centimeters and a height of 4 centimeters is 38.4 square centimeters. That's what you're doing with section 12.1. I'll see you again shortly.